So at the end of the last video, I mentioned how one way to think about vectors is as a collection of numbers. And we'll see why that is right now. So let's say we have a set of axes. We'll call this the x-axis, this the y-axis. Okay, and so we can have some vector v. Typically we write this partial arrow above it. And this is how we represent that it's a vector as opposed to a regular scalar number. Okay? Now, the way we can think about v in terms of these axes is if we just project this down to the x-axis, so this makes a right angle, then essentially we have a right triangle. And you'll notice that we're going to do a lot with right triangles in this class. Most of the geometry we're doing is going to be right triangles used in vector form. Okay? And so the part of v that's along the x-axis we'll call vx, and the height part on the y-axis is vy, right? And so the actual vector v we can write as vx comma vy. Now, your book doesn't actually use this notation. I think it's a nice compact way to write this, and this is the way that if you were taking, calculus-based physics class or pretty much any class using vectors afterwards, this is how you would write it. And this is how you can see that a vector, you can just think of as a collection of numbers, because each one of these is a scalar. So how do we relate this to our previous definition, which said that a vector is a magnitude and a direction? Well, the way we do it's like this. We can say that we make some angle theta with the x-axis, okay? And so the magnitude is going to be the absolute value of v, which is just the length of it. And of course, you probably remember from trigonometry that that's just the square root of vx squared plus vy squared. Right, so that's the magnitude of this vector. And then the direction is just going to be the angle theta. Now, typically, whenever we're doing calculations, we usually want to do this in radians. And we'll see why as we get a little bit further in the class, especially once we start talking about rotational motion. So you can, in some cases, we'll use degrees because I know that's what you're used to, and we'll use that when it's applicable. But especially once we start talking about rotations and angular motion, we're going to start thinking in terms of radians. So if you already know how to do that, it may be good to just start doing that now. So right now I've written down v in terms of its components, but I haven't really said what the components are, right? I've still left it in variable form. So just to give an example, let's say that this is the distance that somebody walked, and v is the path that they traveled. Well, in that case, vx is maybe something like 5 kilometers, and vy, we'll say, is about 6 kilometers. Right? So now that means that we can write v either as 5 kilometers, 6 kilometers, and then for the direction, we need to know what theta is. And theta you can actually get, you may remember the formula that the tangent of theta is going to be the opposite over the adjacent, which in this case is going to be vy over vx. So theta is going to be the inverse tangent of vy over vx. And that's something you can just punch into your calculator and get an answer for. Or if it's a quiz that you're not using a calculator on, you can just leave it in this form, even in terms of numbers, and that's fine.